Okay, so go ahead and take out your highlighters. This is a heavy highlighter lesson, and we're going to do a little art real quick. All right, so I'm going to go ahead and just put up here the colors of the rainbow. So we have pink, technically red, but you know, for highlighters you usually have a pink, orange, yellow, green, blue, and purple. Those are the colors of the rainbow in order, okay? At least highlight a rainbow. You want to do the opposite color. The reason is because you want the solution is going to be where both of your colors intersect, and you want it to be very obvious where that is. So for instance, if you're using pink, you want to use green as your other color because look, when they mix, they become black. Use orange, use blue, use yellow, use purple. So make sure that you're using contrasting colors. For instance, I just don't want you to use like green and yellow because you see how they don't really, it's like green on top of yellow is green. So it's going to get a little bit more confusing, okay? Let's get down to math. All right, example number 1. Y is greater than 2x minus 3, and y is less than or equal to negative 1/2 x plus 2. All right, I'm going to start with the y is greater than 2x minus 3. It is in slope intercept, so I go to negative 3, and then this is 2 over 1. So up 2 over 1, down 2 over 1. The inequality tells me it's a dashed line all the way. And then now I got to think about my test point. So let's just test this point right here. So the test point is 0, 0. So 0 is greater than, remember that goes away, negative 3. That is true. So since that's true, I want to shade in that, that origin. Let's use pink. All right, so then I go ahead, and I got to go all the way up to that line. And try to be careful. I know I'm getting a little sloppy, but... All right, so that's one solution. That's what we did last time, okay? So now if I used pink, remember my opposite color is green. So now I'm going to have a green. I'm going to do this one. This one's in slope intercept, so I go to positive 2 on the y-axis. And then my slope is negative 1/2, so I go down 1 over 2, up 1, left 2. This time I do have that equal sign under there, so it's a solid line. Okay, and once again, I'm going to use this test point 0, 0. So 0 is less than or equal to, that goes away, 2. That is true. Remember, the alligator wants to eat the bigger number. So I grab my green highlighter, and I go everything below, because that includes the origin. And you want to make sure you get everything in there. Now, when I ask you, what is your solution? Your solution is this black area. The green is not the solution. The pink is not the solution. It's only where they mix. So what I want you to do is I want you to go back and outline your solution. Now remember over here it was dashed, so, and all of that are going to be your solutions, okay? And remember we talked about if it's a dashed line, those points do not count. So those points do not count because the boundary line does not count because it's dashed. Versus up here, all of these points do count because it's a solid line. Just a quick little reminder. Here's example number 2. Let me see if I can just steal this. All right, example number 2. Y is greater than or equal to negative 5x minus 2. X is less than or equal to 2. All right, so lucky me, the first one is already in y equals mx plus b, so I go to negative 2 on the y-axis, and then my slope is negative 5 over 1. So down 5, 1, 2, 3, 4, over 1. And then opposite 1, 2, 3, 4, 5 over 1. It's got that equal sign under there, so it's going to be a solid line. I'm going to go ahead and use my origin as a test point. So 0 is greater than or equal to -2. That is true. So I want to shade that entire area. Let's do blue. Okay. So I want to shade above this time because that's where that origin is. All right, now these are linear inequalities. So since these are linear inequalities, if you see this x is whatever or y is whatever, this you actually have to think about Hoy-Vux. Okay, this is an x equals equation, so it's going to be a vertical line. Remember Hoy-Vux. So once again, I just used blue. So the opposite of blue, geez, is orange. So now I'm going to go to x equals 2. I go to the x-axis to 2. This has that equal sign, so it's going to be a solid line, and it's vertical because of Vux. I use the test point 0, 0, which is there, and I plug it in. 0 is less than or equal to 2. That is true. So since it's true, I want to shade in to the left this time because that's where my origin is. So I grab my orange highlighter and I shade this way. Thus, my solution is this black area. And they were both solid lines, so I can keep it solid. Okay? Example number 3. X minus 8y is greater than -64, and y is less than 4x. All right, I gave myself a little bit more room because I knew I was going to have to do some simplifying. So I need to get it into y equals mx plus b, so I subtract x. -8y is greater than -x minus 64. Let's actually move this down a little bit further. And then I divide everything by -8. When I divide or multiply by a negative, I flip my inequality. And then this becomes negative is a positive. 1 divided by 8 is 1/8 x. -64 divided by -8 is a positive 8. Well, that didn't hurt. All right, so then I go to my y-axis to positive 8. And then my slope is 1/8. So up 1, 1, 2, 3, 4, 5, 6, 7, 8. And the opposite 1, 1, 2, 3, 4, 5, 6, 7, 8. It does not have an equal sign under there, so it's going to be dashed. And then I'm going to try out point 0, 0, so, which is here. So 0 is less than 8. That is true. So I grab my highlighter and I go downwards so that I include the origin because that is a possible solution. And do you notice how I'm coloring everything in? You need to too. Don't be sloppy. Okay. Over here, it's already in y is less than 4x. So if you want to, and I like to, I put plus 0. Okay. So I go 0 is my y-intercept, 4 over 1. So up 4, 1, 2, 3, 4 over 1. Down 4, 1, 2, 3, 4 over 1. It does not have an equal sign under there, so it's going to be dashed. This time, I cannot use the origin as a testing point because it's already on the line. So the easiest one to me is that 1, 1 right there. So I'm going to go ahead and plug it in. So 1 is less than 4 times 1. 1 is less than 4, and that's true. So since that's true, I need to highlight to the right because that's where that point is. So I grab my highlighter, the opposite of green is pink, and I highlight that area. Try to get it as close to the boundary line as you can. And once again, my solution is all of this. And both of them were dashed lines, so make sure you dash them. And one more, guys. All right, example number 4. All right, you have x plus y is greater than negative, or greater than or equal to, oh, sorry, just positive 3. It's a positive 3. And then x plus y is less than or equal to negative 4. All right, so the first one, I subtract x over. Y is greater than or equal to negative x plus 3. I go to the y-axis to positive 3. This is a negative 1 over 1, so down 1 over 1, up 1 over 1. It's got that solid line, or the equal sign, so it's got a solid line. Okay, I test out my point, 0, 0. Let's do it here. So 0, which is going to be here, is greater than or equal to a positive 3. That's false. So since that's false, I have to shade the opposite area. So I'm going to shade opposite, which is this side, because that is not a solution. Over here, I do the same thing. Subtract x. Y is less than or equal to negative x minus 4. So I go to negative 4 on the y-axis. This is negative 1 over 1, so down 1 over 1, up 1, left 1. Once again, it's got that equal sign, so it's solid. I use my test point 0, 0, once again right there. So 0 is less than or equal to negative 4. That is also false. So I have to shade the opposite side of where the origin is, which is this way. Come on in, come in. I'm almost done. So now I look at it, and if I'm looking at my colors, there's nowhere that they intersect. So if they can never intersect, I don't have a solution. So this would be an example of no solution. Now remember, you have to have parallel slopes for this to happen, because those shadings are never going to intersect. Okay. All right. Here are your practice problems. And I want you to go ahead and have all of them drawn and shaded, and I want you to make sure that you make it very clear which is your solution area, okay?